Hello and welcome to another video on linear programming. This will be discussing capital budgeting models. So a capital budgeting model, we first need to define the net present value, which is used to determine the current value of all future cash flows generated by a project, which includes the initial capital investment. So we will use the formula. Write it out here. T equal to 1, T equal to the future value of T, C of T, 1 plus R over T. I'm going to write this out in a little more layman terms. We have the summation of the investments from T, or from 1 to T, with the cash flow in year T, the year you're looking at, plus 1 over, this is over, 1 plus the discount rate of the money. This is usually given in your problem. And then also to that T, the number of years. So we'll just have a real quick short example. Your initial investment, year 1 and year 2. So your initial investment is going to be minus $5,000. In year 2, you're going to make $12,000. But in year 3, we'll do $15,000 here. And in year 3, it's minus $12,000. So here's how this is going to look. And your discount rate is 10%. So we're going to start out by doing the minus 5,000 plus 15,000 over 1 plus 0.1 to the 1 plus minus 12,000 over 1 plus 0.1 to the 2. Now if you plug this into your calculator, you should be able to get a net present value of 1280.99. That's just a real quick example of the net present value of this investment. Now we're going to go and look through an actual example of a linear model using this net present value. Let me mark that off. Example 1. The initial investment, or the investment company is considering 6 different opportunities for investment. Cash outflows and net present value are given in the table shown. The investment company has $35 million available now and will have $20 million available 1 year from now. Any money not used now cannot be invested 1 year from now. The investment company needs to maximize the net present value that can be obtained in investing in investments 1 through 6. Each investment can be partially funded but will affect the total net present value. So let's look at this. We have our table of investments, so that's investments 1 through 6. So let's start off, of course, with our objective function. You can see already to maximize the net present value. So we're going to do that. Maximize net present value. We're going to set that equal to Z. But we'll define Z in a little bit afterwards. And now let's do our decision variables. Alrighty. So we're going to have to be a little careful. We know that our decision variable is going to be some form of investment. But we also know that we can invest in fractions. It can be partially funded. So our initial investment, our decision variable, is going to reflect that it can be partially funded or that it can be a fraction. So this will be a fraction of investment into project I. I representing investments 1, 2, 3, 4, 5, and 6. So now we can go back knowing that we have this decision variable. We're trying to maximize this variable here. We're going to go back to our z, and we know that the fraction x1 times the net present value of investment 1 will give you that value. So we're going to go through and we're going to do x2 times 15 plus x3 times 15 plus x4 times 13 plus x5 times 40 plus x6 times 11. So this is the fraction of each initial investment, or the fraction of each investment into this value, which will give you the net present value. Now let's go through our subject, or our constraints. So of course we have a constraint here, 35 million available now. So now. We know that x1 times the fraction of the investment into project 1 costs that fraction times 15, or 15 million. x2 is times 50 million. x3 times 8 million. x4 also times 8 million. x5 times 30 million. And x6 is times 5 million. And this has to be greater than 35 million. So that's our constraint right there. 1 year from now, we're going to do something very similar. Our fraction in that investment is going to be times 5. Fraction in the investment times 10. Fraction in the investment times 8. Fraction in the investment times 3. Times 35. And then we're going to do x6 times 2. And now this is equal to 20 million because it specifies in here that money not invested now cannot be invested a year from now. Now we also need to define that this is a fraction. Our investments are in fraction form. So x of I must be less than 1. This defines all fractions of the investment. You can't fund a project 2 times. So that would be 4. I equals 1 all the way through 6. And then, of course, we need our non-neg. X of I has to be greater than 0 for I equals 1, 2, 3, 4, 5, and 6. So this is going to maximize our net present value at Z. And this is a simple capital budgeting problem. Thank you for watching, and I look forward to making more videos.